Third one is hardening. Okay, and hardening is also known as quenching. Okay, the other name is quenching. So what are the purpose? To increase the hardness and strength by forming the martensite. I have already described in the second or third in what is martensite, what is benite, what is pearlite, iron carbon diagram, right? And at what temperature these all formations occurs. So increase. So obviously, its name is hardening means we are basically increasing the hardness of the steel. So in this process, we are interested to increase the hardness of material. So that's why we are doing. Sorry, we are we are having the name hardening. So name is just suggested by process. So how can we do that? Okay, how can we get the increased hardness? Here is the process. The heat the steel to a temperature above the upper critical temperature. Right here, we have done. We have reached upper critical temperature. So above the upper critical temperature, but here we were here we are also above the upper critical temperature. So in the both the cases, if we talk about normalizing or for the hardening, we are reaching the temperature above the critical temperature. Critical temperature is the same where the crystalline structure gets changed, then it is a critical point. Before that, if you raise the temperature, the crystalline structure will not get changed. It means the transformation will not change, the phase change will not occur. Okay, but and what is the critical? I mean, if you will raise the more temperature, then it will get melted. That is the phase transformation. That is a solid to liquid. That is a different thing. That we are not getting at that point. Before that, I mean, we are not reaching the melting point. Before that, we are having the critical point where you can say at that particular temperature, if you will be before that, it means you are not allowing material to recrystalline. I mean, the crystal structure will not get changed. But if you have just crossed that limit of temperature, then you would be having your material getting structure changed. And if you will raise the more and more temperature, and then if you reach at the melting point, then your whole material will get changed, okay, into the metal. Okay, they will start melting. So that is basically changing the shape. Okay, but what the condition that we have met here, we have set here, that is we cannot change the shape of the material. It means we cannot melt the material. That's it was the first at the beginning in the definition of heat treatment, right here. Where I have written, yeah, without changing their shape. The shape will not change. It means only the crystal structure is being changed while we are doing the heat treatment. Okay, so heat treatment, I mean, two kind of temperature. First, you need to know the critical temperature where, and upper that you would having a melting point, a melting temperature. So we are very lower than at a very lower temperature with a melting point. Okay, and at that temperature we are having two kind of criteria. First, before that you would be having your crystal structure phase changes, and if you have just crossed the limit, because the limit of the critical temperature, okay, also known as the crystalline temperature. And before that, the it will not get it will not allow your material to get their crystal structure changed, so phase change will not occur. So in the both the cases, we are just raising the temperature above the upper critical temperature. Okay, so hold at this temperature for the short times while the cooling into the air. So here we are what we are going. Sorry, what we are yeah, here quenching. So upper critical temperature and hold at this temperature for to achieve the fully austenitic structure. So what we are doing here, martensite is being converted into austenitic structure. So material internal structure is getting changed, martensite to austenitic structure, or austenite you can say. So rapidly, what we do after that, we do the rapid cooling. Rapid cooling how? Which is rapid cooling is known as the quench, and in water or oil or air, depending on the steel compositions. So we have three options where we can, but all the options are there. Like if we would be having, doing the cooling by air, you can say, yeah, this is the same process as we done in the normalizing. No, if you are just rapid cooling, then air must be having a very low temperature. They are having very high speed, so that it will affect your material, and the material will get cool very soon. Okay, and you can easily think about in water. If you have heated or something, you will just keep inside the water, it will get easily cool and very soon. Similar to that, the oil has a normal temperature. Okay, so this is the process while we are doing the hardening. Okay, so by doing this, we are having a high hardness. Okay, so we can increase the hardness by doing the hardening, or we can say the quenching. Okay. Okay, so what are the microstructure that we get here? The martensite. Okay, the hard brittle phase. So obviously, if hardness had increased, it means we have come into the brittle materials. Okay, so we have just changed the brittle, and you can say in other words that we have lost the ductility. Okay, so in the process, the ductility will decrease, and at the same time the brittleness will increase. We talk about the application parts used for the tools, gears, and components require the high wear resistance. So wherever the high wear resistance is required for that material, we must be having the high hardness, so that the wear will not be seen over there. For that, we must need to do the hardening before that is being to you that is being used for the final component. Okay.